Good evening. Today we are going to solve the problem of moment distribution, and that is of sway frame. So already we have solved partly in the class. So you can check that one. So solve solve portal frame as shown in figure by moment distribution method. By moment distribution method. Moment distribution method. Now we have all three types of load you can see over here. So we have one end fixed and other end we have simply supported. Load on this we have 60 kilonewton. UDL we have 40 kilonewton per meter. So 40 kilonewton per meter. Then 6 meter, 2 meter, 2 meter. Then 50 kilonewton, 1 meter, 2 meter. Then value of EI for AB, we have 2 EI. And for this, we have 3 EI. Now I will go little bit fast for step 1 and step 2, which we have already solved in the class. Our main part, that is sway analysis. So step 1, type of frame, sway frame. Sway frame. Now we have MFAB is equal to minus WL by 8 minus WL by 8, and we will get it as minus 30 kilonewton meter. And now we have MFBA WL by 8, and we have this value as 30 kilonewton meter. Then go to MFBC, we have UDL. So it is minus WL square by 12 minus WL square by 12 gives us minus 121. And if we will go MFCB, then we have WL square by 12. And this value comes 120 kilonewton meter. Now, if you will switch over to the last span, MFCD, which will be minus WAB square upon L square equal to minus 50 into 2 into 1 square upon 3 square. This comes minus 11.11 kilonewton meter. And MFDC, we have WA square B upon L square, which will be 50 into 2 square into 1 upon 3 square, which will be 22.22 kilonewton meter. Then we have step 2, distribution factors. So we have step 2, distribution factors. Distribution factors. And then we have at joint B, we have stiffness of BA Stiffness of BA. A is fixed end. So we have 4 EI by L, and we have 4 EI value, we have 2 EI upon 4, and that is equal to 2 EI. Now if we will go to stiffness of BC, stiffness of BC, C is continuous. So it is again 4 EI by L, and we have it as 4 EI by 6, and that is 2 by 3 EI. And therefore we will get total stiffness at B. Total stiffness at B, if you calculate it, then 3 2s are 6, 6 to 8, so it will be 8 by 3 EI. Then we have distribution factor of BA equal to stiffness of, denoted by gamma BA, equal to stiffness of BA upon total stiffness. Total stiffness. Now you can see stiffness of BA, we have 2 EI. Upon total stiffness, we have 8 by 3 EI. And if you calculate, you will get value as 0.75. Now we can have gamma BC. Stiffness of BC, we have 2 by 3 EI. Upon total stiffness, we have 8 EI by 3, and this comes 0.25. Then we have at joint C, stiffness of CB, we have same as stiffness of BC. So it will be 2 by 3 EI, no change. Stiffness of both BC and CB should be same. And then we have stiffness of CD. Now as we have D simple support, so it will be 3 EI upon L. We have 3 EI, we have 3 EI. Upon L we have 3, so it will be 3 EI. And therefore we will get total stiffness at C. So we have total stiffness at C, and that is equal to 3 3s are 9, 9 to 11, 11 by 3 EI. Then we have gamma CB, stiffness of CB, 2 by 3 EI upon total stiffness, 11 by 3 EI, and that comes 0.18. And gamma CD, we have 3 EI divided by 11 by 3 EI, and this value comes 0.82. So we have to keep in mind total distribution factor at each joint should be 1. If it is not, then you have to check it and do it 1. This is most important one. Then we have step 3. So till this, we have same as non-sway analysis. So we have step 3, non-sway analysis. Non-sway analysis. Now I will go little bit fast for this non-sway analysis, because already we have done this non-sway analysis in the class. So now we will go with, so we have first joint. So we have four joints. So we have joint A, then we have joint B. At joint B, we have two members. So member BA, member BC. Then we have joint C. At joint C, again we have two members, CB and CD. And then we have joint D. And at joint D, we have only one members. So we have member AB, then we have BA, BC, then we have CB, then CD, and then we have DC. Then we have fixed end moments. So we have fixed end moments. So we have first value, that is of fixed end moment, minus 30 for AB, plus 30 for BA. MBC we have minus 120. Then we have 120 minus 11.11 and 22.22. Now as joint D is simple support, so we have to release C. Release C. So release means we have to make it 0. So minus 22.22. And then we have carryover of this, which will be minus 11.11. So we have this will be carryover. And from this we will get total moments. So we will have total moments at this. So this is most important when we will add afterwards. Then we have to add from total moments. So total moment. So we have this will be minus 30. We have this will be 30 minus 120, 120. Then we have minus 22.22 and 0. So after this, we do not have any carryover for DC. Now we have these values, that is for BA and BC. We have these values as 0.75 and 0.25. For CD, we have these values 0.18 and 0.82. So 0.18, 0.82. And then we have distributed moment. So now I will change the sign so you will understand it easily. So we have distributed moment. So at joint B, I have distributed and value I will get. I will not go in detail with this again. So this is 67.5. So we have 67.5 and then 22.5. Then we have minus 17.6 and then minus 80.18. Minus 80.18. Now we will go carryover. So carryover we have we will go for carryover. We have this value. So just we will see it. So carryover half of this we have 33.75, half of this. Then we have 11.25, then minus 8.8, and then we do not have carryover on this side. So after this, we will go for distributed moment. So now which values we have to distribute? A value at this we have 0. value at this also we have 0. So we have to distribute 8.8 and 11.25. So at this we do not have any value, so it is 0. Here also we do not have value 0. So minus 8.8 into 0.75, opposite of this. So 6.6. Then we have this as 2.2. Then on this side minus 2.02. And then on this side minus 9.23. Then we have carryover. So we have carryover of this is 3.3. Then carryover of this 1.1. Carryover of this minus 1.01. We do not have carryover of this. And then we will go last distributed moment. Now again we do not have anything for BA. We do not have anything for CD. So we will have distribution of this minus 1.01 will be plus, and we have this value 0.76. Then we have 0.25. Then we have minus 0.2 and then minus 0.9. And then we have, after this distribution, always we have to stop at distribution. So if do not have any value for distribution, then we can stop it at final moments. So now we will go with final moments. So we can have this value, just I will write this will be 0. So this will be final moments. We have this value 7.05. Then we have this value 104.86. Then minus 104.86. Then we have 112.53 minus 112.53. So these are moments due to non-sway analysis. Then we have sway analysis. So step 4. Sway analysis. Now in sway analysis, I already mentioned we have to consider moment, that is minus I1 upon L1 square. This is for column only, is to minus I2 upon L2 square. So I1 means this is for AB and this is for CD. So for AB we have minus 2I and upon 4 square, span is 4, and for CD we have minus 3I and span is 3 square. From this we will get this value minus 1 by 8 is to minus 1 by 3, and therefore we will take this multiplied by cross multiplication, and so we will get minus 3 is to minus 8. Now values we are going to get very less, so we will go little bit higher side, multiply by both, and values we have minus 30 and minus 80. So now we have fixed end moment for AB equal to BA. We have now same, which will be minus 30 kilonewton meter. Keep in mind, for non-sway analysis, we have value 1 plus second minus. Here we have same sign conventions. MFCD, MFDC, we have these values minus 80 kilonewton meter. And now we have to go for sway analysis. So we have step 4, moment distribution table for sway analysis. We have step number 4, 5. So we have distribution table. Now we have to prepare in the same fashion distribution table. So I will just prepare it first. So we have first, so joint. Then we have joint A. So I will take it down now only. Then we have joint A. Then we have joint B. Then we have joint C. And then joint D. And then we can have members. BA, BC, CACD. So just I will write it. Member AB, BA, BC, CB, CD, and DC. Then we have fixed end moments. So just we have seen, so we have fixed end moment for AB and BA. We have these values as minus 30. This is also minus 30. No moment for beam, so it should be 0. And for this, we have minus 80 and minus 80. Then we have to release. So release D. So we have this value we are going to release. So we have this value plus 80. And when it will be carry over, so we have this value as plus 40. And then we can have these values. So now we will go with total moments. So we have total moments. Total moments. So this will be minus 30, minus 30. Then we have 0, we have 0. This will be minus 40 and 0. Then we have distributed moment. So we have distributed moment. Now I will write values. So we have 22.5, 7.5. So 22.5, 7.5, and 40 will be 7.2 and 32.8. Now you can distribute it by considering distribution factors. So I will write distribution factors here. So we have distribution factors 0.75, 0.25, and here we have 0.18 and 0.82. Now we will go with after distribution. We have to go for carryover. So we have carryover this value 11.25. This carryover will be 3.75. This carryover will be 3.6. This carryover will not be there. Then we have distributed moment. So distributed moment. So now we have distributed these values and I got minus 2.7, minus 0.9, minus 0.68 and then minus 3.08. Then we have carry over. So we have this will be minus 1.35. Then we have this carry over minus 4.45. Then this will be minus 0.34. There we do not have carry over. And then we have large distributed moment. And we have this value 0.26. So we have 0.26, 0.08. Then we have 0.08 and 0.37. And then we have total final moments over here. So we have final moments. Now we have value 0 over here. Here I got value minus 9.9. Here we have value 9.9. Then 9.94. Minus 9.94. And then we have minus 20.1. These are my final moments. And now we have to find these values of the moment 30 and 80, minus 30 and 80 we have assumed. So we have next step, correction factor. So we have step 6, correction factor. Now we have summation fx equal to 0. And then we have to find HA, we have always considered positive. So this will be HA. And then we have load that is 60 kilonewtons at 2 meters. And as our sign conventions are positive, so we have to consider this MBA and then we have to consider this as MAB. And from this we will find value of HA. So we have moment about B equal to 0. So we will get minus HA into 4 minus 60 into 2 plus MAB plus MBA, and that is equal to 0. Summation fx 0, we will have horizontal forces HA at support A, HD at support D, plus 60 because on AB we have towards right, minus 50 on CD towards left, and therefore we will get HA plus HD equal to minus 10. And then from this we will get value of HA that is equal to MAB plus MBA plus minus 120 upon 4. Now if we will go for CD column, then we have this will be HD and we have this as 50 kilonewtons. This is 1 meter, 2 meter. Now we have only moment on this clockwise MCD, MDC we have 0. And if we will take moment about C0, then we have minus HD into 3 plus MCD, then plus 50 into 2 equal to 0. And we will get HD equal to MCD plus 100 upon 3. Now what are values of MAB and MBA? So we have this will be MAB, MBA. Now MAB we have MAB due to non-sway plus MAB due to sway. Now you can check your values. So due MAB due to sway, we have 7.05. Then non-sway, we have to multiply it by C because we do not know its value. So we have, this will be minus 20.1 C. Then similarly, you can find MBA, which will be equal to 104.86 minus 9.94 C. 9.94 C. Then we have MBA, then MCD. So we have MCD that is equal to minus 112.53 minus 9.9 C. Now you have to put these values in HA. So we have HA that is equal to, if I will put it 7.05 minus 20.1 C plus MBA we have 104.86 minus 9.94 C and divided by 4. Divide by 4. Then we have MHA, then we can find value of HD. We have MCD minus 112.53 minus 9.9 C and plus 100. And divided by 3. Now from this you have to substitute this value of HA and HD in this equation, and then from this you will get value of C. And by solving this, so if I will solve this, then I will get this value of C. It will take time, so I will not solve this. So find value of C and then put this value of C in this equation. And from this you will get final moments MAB, MBA, MCD, and then you have to plot bending moment diagram. So now we will stop here only. Remaining part we will see in the next lecture. Thank you.